Okay, so welcome everybody again. Thanks for joining in on this Wednesday morning it is for us. I'm not sure it's morning for everybody. We'll be talking today about test feedback and getting essentially fast feedback from our tests. So while I'm trying to get to the next slide, because that's where we headed. My name is Sven. As I said already, I'm in the role of the moderator today. So my job will be to take on your questions during this talk in the chat or in the audio. We're a small group, so I'm sure we will have sufficient time to discuss all of your questions. Our goal here in the workshop is to have as much interaction as possible. So please, if you have any input, ideas, questions, doubts whatsoever about the contents of this workshop, jump in and ask your questions right away. We'll all have more from participating here if we have more discussion. Even if it's not a well-formulated question or doubt that you have, just shoot. I'm sure we can figure it out here in the session and get to an answer. If that is more comfortable for you, also feel free to ask the questions in German. Both myself and the speakers are native German speakers, so we can take the questions and then translate them or make that in a mixed way, hopefully work for everybody. And last organizational point, we also would like to get some feedback from you on the workshop itself in the end. So after the workshop and when you leave the meeting, we will open a feedback poll for you, and we would be happy to get some input on how we can further improve our workshop format here as well. That being said, maybe a couple of words on CQSE and Teamscale as a background here, because there's some people in the room who don't know us yet. We as a company are exclusively focused on the topic of software quality. Today we're spread out quite far over Germany. We already learned that the first 3 employees introduced themselves here today are sitting in 3 different cities in Germany. We also have an office in the US meanwhile. Depending on where you're sitting, it's not unlikely that we have an office nearby. Despite our geographical spreading out, we're still very focused on the topic of software quality for 15 years by now, building Teamscale as a platform around software quality and as the product that many of you are already familiar with and that we'll be talking about here today. More specifically, we're today talking about the topic of test selection. So how do we ensure that we invest our scarce test resources in the best possible way to get quick test feedback? And that this is an interesting topic across industries and technologies is something that you prove by being here today. I have here the logos of all the companies that registered by last week. That being said, I don't want to defer any longer and hand the microphone over to Raphael for the first part.
Thank you very much. Then I will take over the sharing. And then get started. First, a few words about myself. I am working in the test intelligence team at CQSE. What we do is we help our customers with setting up these test-focused analyses like the ones I will present today in the talk. And also with 50% of my time, I'm doing research. I'm working on my PhD, also in the topic of test optimization. So how can we make execution of tests more efficient. Okay, and then with that, let's dive right into the topic. When I think about software tests, I often imagine a pyramid as the quite common display of how tests are, or at least should be, distributed in many systems, where we have lots of unit tests at the bottom and fewer higher level tests like integration tests, system tests, and UI tests towards the top. And these higher level tests, they do provide a lot of additional value because they can find faults that these unit tests cannot, like faults that only appear when different components are playing together, but they usually take a lot longer to actually execute. And in addition to that, they often cannot be parallelized as easily. And for various reasons, for example, they can depend on external systems, they might be difficult to virtualize, or they even need some specific hardware that makes them difficult to just arbitrarily parallelize. A couple of examples from some of our customers to how big this can get and how big of a problem these long-running higher level tests can get. We have one customer who builds a work time management system. Their tests last for around 500 hours if run in sequence. 500 hours, you can imagine, a bit long. So what they did is they parallelized quite heavily and run it on around 50 machines in parallel. So that's about 10 hours roughly left. So they can just about run it overnight. But with those 10 hours, they only tested one single version. So this means all the other versions will remain untested for this day. And I only get feedback on this one version. And even there, I cannot test every commit, just whatever state happened to be at the end of the day. And as I mentioned, all the older versions will not be tested. They might be tested once per week on the weekend or whenever there is additional time to run these tests. Another example, even more difficult to deal with, is this hardware in the loop tests. Here we can see on the slide a hardware in the loop test stand. So these require specific hardware that needs to be acquired to actually run these tests. And for our customer, this meant they needed 20 days to run all their tests, with tests running 24/7. So as you can imagine, these tests won't be run very often. They will maybe be run once per release. And yeah, I won't get feedback very frequently on any of this. And yeah, implementing any of the feedback will take quite a long time. Yeah, and to deal with these kinds of issues, we have implemented test impact analysis, which is the first of the two analyses that I want to present today. The basic idea is, instead of executing all the tests, every time I execute tests, I will choose tests that cover the changes made. And to give an example of what this can look like, I brought our own system, Teamscale, and here is a visualization of that called a tree map. We use tree maps quite a bit, so I will briefly introduce it here. Here we have a quite high-level tree map of the system, and each component is one of those rectangles. So we have different components in Teamscale. Each of them is represented as a rectangle here, and the size of it is represented by the lines of code inside. So the bigger the rectangle, the more lines of codes are contained in it. And then I add a bit more detail, and I add the classes that are in Teamscale. So here now every rectangle is one class. And again, the size of the rectangle represents the lines of code contained in the class. And we do the same exercise one more time and go down to the level of methods. Here, these small rectangles now are all the methods in Teamscale, and still remains consistent. The size of the rectangle represents the lines of code in the method. That's all the spatial detail we want to add here. Then we will, in addition, add some colors. And we want to look at a change in Teamscale, specifically one of our tickets. So we implemented Java closure support, And this tree map now shows the changes that were made for implementing Java closure support in Teamscale. So the gray ones, the gray boxes here were unchanged. So these methods, nothing happened. They remained as they were. And the darker orange or red ones were newly added. So these didn't exist before and were added for this ticket. And the yellow ones were modified. So they were changed in the course of this ticket. And in just a second here, I will play a little animation that shows how our test suite runs through the system. And what this will look like is, first we will see in white, you can already see a few white spots here, the new methods that are being tested right now, and then they will fade out to green, and always the new tests that are running are shown in white. So let's see what happens when our test suite runs over Teamscale, or a part of our test suite actually. We can see that fairly quickly, quite a few parts of the system are getting covered. And we have a lot of tests running. And what quickly becomes evident is very few of our tests actually run through any of the changed parts, so the red or orange parts. And yeah, I guess this actually makes quite a bit of sense. Most of our tests are not relevant for Java closures in Java 8. So these tests won't cover any of those changes because Teamscale does a lot of other things. Teamscale does not only static analysis, and Teamscale does not only do Java, but also a bunch of different programming languages. So most of the tests have nothing to do with this. And that is exactly what we want to use in test impact analysis. Let's look at this in a slightly different visualization. Here we have an example test suite. So this is some very stylized tree maps. And each tree map here represents one test case. And the green part is meant to show the part of the code that is covered by the test case. And we will use these to explain how test impact analysis works. It roughly does 2 steps. Before those steps, we first have to record where each test case runs through, and then we basically get this list of our test cases with coverage. And then the first step is we want to select tests for change. So we throw out all the tests that don't run through any of our changes. So we have quite a bit fewer tests, hopefully. And yeah, in most cases, this leads to a significantly smaller test suite because we only have the tests that actually are relevant for our changes now. But there are some scenarios where this can have rather little benefit. For example, if we imagine some end-to-end tests, and each of those end-to-end tests goes through a login screen, and then we make some changes to the login screen. Every single one of those tests will be affected by those changes. Not majorly, but it will be affected. So if we make changes in central places like a login screen or maybe some database layer where every test goes through, we might still have many or a lot of tests selected. And for this, we added a second step. And that is a prioritization of these impacted tests or of these relevant tests. So what we normally have is we have a bunch of tests and we have failure somewhere among them. We don't know where. And ideally, we would like to have our failures appear as early as possible. So we can start fixing the things early and we get feedback very quickly. And maybe we can already start the next test run earlier on then and don't need to wait for the whole test suite to execute. So ideally, we would like to have this picture where all the failing tests are at the very beginning, but that sadly is rather hard to do, basically impossible, because if we already knew which tests were failing and we put them at the start, then we might not even have to run them in the first place. So what we do instead is we go to a research field that is called test case prioritization. And they looked at a lot of different techniques that analyze how you can order tests to have failures earlier. And we found that one pretty efficient means is to use change coverage per execution time. So we look at we put the tests at the start that have the most change coverage in the least amount of time, and more specifically, additional change coverage. So changes that previous tests did not yet cover. And with this, we might get something like this, where the failing tests are fairly early, and we can maybe stop test execution after we had some failures, and we don't need to necessarily run the whole selected test suite. So that's the basic concept. And then we did some research on this to evaluate this technique. And what we did was we compared the results of test impact analysis to the full test suite. And we looked at how many of the overall faults can we find with 1% of the test execution time, 2%, 3%, and so on. So if we only use 1% of our total test execution time with test impact analysis, how good will we be compared to the full test suite? And we did a bunch of research papers on this, and some of them looking at real historical errors from open source systems. Some of them looked at artificial faults introduced with mutation testing. And what we found is that in 1% of the test execution time, we can find 80% of the overall faults in the system. And if we are generous and use 2% of the time, we can find 90%. Now, these numbers look almost too good to be true. This is actually not because of these algorithms being super genius or very specific, or at least not only, but they are actually because retest all is just extremely bad. So if you make a change in a small part of the system, running the whole test suite is just extremely inefficient. And that's why this technique can give such a big benefit, because it uses this huge potential for optimization that is there when you just retest everything every single time. All right, then how can we set up this technique, or how can we actually use this technique? There are two steps involved, or two main steps involved. The first is to record test coverage. This is done during the test execution. So we need to execute all of our tests. And then we attach a profiler that runs in the background. And this records for every single test which parts of the systems are covered and how long did every single test run. These data we then upload to our system, Teamscale, where this analysis happens. And then the second step is the integration in the CI pipeline. Here we need to connect Teamscale to the version control system. And from there we get the code changes. And then we also use this for our analysis. So we look at the changes, look at the coverage, and then we can make a test selection and test prioritization. So the two steps I mentioned before. Teamscale does this automatically, and then can give an ordered list of impacted tests for a given set of changes that you can decide on. So for each single test run, we then basically make this selection, and we can quickly find new bugs with this. Any questions to this technique?
Yeah, thanks a lot. And how do you share the list of impacted tests? Because I think the development team needs to reorder the tests on their side, or how do you achieve it?
So what basically happens is normally this, for an quick question, is this for automated tests or for manual tests?
For me, for automated tests.
Automated, okay. Then the development team is basically not involved once this is set up, but the environment will just, or the testing environment will query Teamscale for these impacted tests. And Teamscale then returns the list in the right order and with only the selected tests. So you get back a list, and your test environment then needs to execute these tests. So that's one capability that is necessary. We need to be able to order to execute a subset of the test suite and yeah, basically it's just another step in the test execution where there needs to be a query to Teamscale right before, and yeah, then it can be run by the test environment. Does that answer the question?
Cool. Yes, thank you.
Okay. Any other questions? All right, seems to not be the case. Then I will continue with the second procedure before we get to the demo. So there are a few things I did not mention so far. What I've shown here is quite a bit of a simplification, and it can be quite a bit more complicated in practice. I usually have many branches that my tests are running on, and I'm running many tests per day. This can result in gigabytes of data generated each day with this with the test-wise coverage, and also there are quite a lot of different setups, and integrating or running different tests each time might be challenging for some. And so depending on the type of setup that we have, setting this up and maintaining it can be quite a bit of effort. So what we did for the second technique is we asked ourselves, isn't there a simpler option that I can use that gives me good results, but with less effort to initial setup and to the maintenance? And what we did is we tried to not look at the changes, but just make a selection by using the redundance that is often present in big historically grown test suites. So often you have tests that check for very similar things, and they usually fail together. And we try to use this to select a subset of tests that achieves a good fault detection rate on average. And I will give an example to make this a bit more tangible. So again, we use this visualization of test cases here. And in many cases, there are faults that cause many tests at once to fail. So here we have this orange bug that causes these two tests to fail. We have the blue bug that causes these 4 to fail, and the purple one, only that one. And what we try to achieve with Pareto optimization, the name of the second, I think I didn't mention yet, the name of the second technique is Pareto optimization, is to select one representative of each bug. So one test that fails for each bug, at least one, so we can still find most of the bugs with a lot lower test execution time, with a lot less effort in testing. And often having one failing test is already enough for the developer to fix the fault, and I don't have to run my whole test suite to find these. I can run the short Pareto optimized test suite. So that's the conceptual side. We want to look in a bit more detail now on why is there this potential for optimization at all. For the first technique, it was quite obvious. Depending on the change, different tests are relevant. So I pick different subset of my tests that are really targeting this one or these changes that happened. Now we want to make it simpler, so we do not pay any attention to the changes, and this only makes sense if there is still potential for optimization in the test suite itself, because we don't look at changes. So we try to exploit the structure of these big historically grown test suites. And why this works and why there is potential, I want to show with another example. So what we used here as an example is this painting program that's called Pixelitor, implemented in Java, and it's an image editing program. Can imagine it in power somewhere between MS Paint and Photoshop. So yeah, a simple GUI Java application. And I think everyone can roughly imagine what this can do. Everyone has probably used some kind of image editing at some point in their lives. So again, we use tree maps, and we have here the packages of the Pixelitor. And then as before, we add some more detail. We look at the classes and finally the methods. And again, we do some coloring. This time, as I mentioned, we don't look at changes. So we only cover in green what the tests cover. So this is a small part of the test suite, and this covers these methods marked in green here. And then we split that up into the 25 individual tests. And here we have now, for each single test, which parts of the code are covered. The tree maps look rather similar at this level. They do have some different coverage, but maybe you can already see that within one line, they look quite similar. If not, I will show it in a second in more detail. And what we want to look at now is how does the execution order affect how quickly we cover different parts of the system. So one crucial element that we use here is that often tests are executed folder by folder and test by test. And that means we usually have similar things tested right behind each other. And if we look at this example test suite here, we now have one of the tests in detail. So this is the first test Gaussian blur. So some kind of blur filter that makes the image blurry that we are looking at. And in green, we have the coverage. And now if we look at the next test, we will introduce another color. In blue here is everything that was already covered by another test. So green are the things that are newly covered, and blue is everything that has already been covered by a previous test. So these things are covered again here. So we are less likely to find any new faults in there. It's not impossible, but it's less likely. And we can also see in the name, test motion blur, it's quite a similar test. So again, a blur filter, just a different one. And next test, we can see even less green, less newly covered methods, and again, a similar test. And the last one we look at here basically barely covers any new functionality. And this is also what we mean with redundance. So it tests most of the things it tested have already been tested before. And we know from studies that often either all of these tests will fail or none of them will fail. There are, of course, very specific cases where only one of them might fail, but in most of the cases, and we are optimizing for most of the cases here, it's like this, that all of them will fail together. So what we can do is we can get a good cost to benefit ratio if we execute only one of them. Okay, so now we look at this coverage in a different visualization. We look at how does it develop over time. So here on the x-axis, we have the execution time, and on the y-axis, we have how much of the overall test suite has been covered. And we can see for a normal test suite execution, this is somewhat of a staircase. Maybe when a new folder or is being executed a new type of tests, we get a big jump, and then we stay on a fairly similar level for a lot of tests that execute similar things. And now let's look at how we can improve this. So what we do is we just modify the execution order. And the idea of Pareto here is to cover as much code in as little time as possible. So what we do is we always pick the tests that creates the most additional coverage. So coverage that has not been generated before per time unit or per second. So the first test then is test create and modify selection. As you can already hear from the name, this is quite a different test. So we picked a completely different test to start with. And if we go through, we can see some things are still colored in blue. So they have already been covered. By the nature of end-to-end tests, this will almost always be the case. But we still have quite a bit of new coverage in green. And if we go through 4 tests like we did before, we can see that even in the last one, there is quite a bit of green left, a lot less than at the start. As I said, end-to-end tests, but we still have some additional coverage. And for a slightly different visualization to emphasize this, we have on the left side here the unoptimized order, and here we picked out all of the methods that are being covered, and we put them in kind of a bar chart. And we can see that the bar at the start in green is quite big, and then it's mostly blue, and it gets very, very little green towards the end of the regular execution order. And by comparison, if we look at the Pareto optimized order, we can see that we have a lot more green at the start, and even at the end, they are almost equally sized. So we still have quite a bit of additional coverage where we can detect new faults. And also, if we look at the chart from before again and order this by Pareto optimization, we can see that slide doesn't want to switch. All right. We can see that we have a much steeper climb now. And the idea of Pareto optimization is now if we, for example, cut off at the green line here, then we have around 10% of the overall execution time, but we have 99% of the methods covered that we covered before. So almost everything in the system will be covered once, which gives us a good chance of finding some faults there. All right, so how much do we gain from this technique? We did similar analysis as for the previous technique. So we looked at different execution times and evaluated with real faults and artificial faults introduced by mutation testing, how fast can we find the faults that the original test suite finds. And here, if we gave 6% of the overall execution time, we could find 80% of the faults. So we need a bit more, but we are still vastly better than the standard execution order. And if we give 11% of the execution time, we can find 90% of all faults. So this is worse than test impact analysis, which is not surprising. We use less data, we are less precise here. Instead, we use a heuristic that is optimizes for covering as much of the system as possible. But this is also quite a bit easier to set up. As a reminder from before, for test impact analysis, we need to know for every single test run which part of the system changed. And then we have to query Teamscale to get this list of ordered and impacted tests, and have to integrate that in our CI pipeline. Now we remove this step, and all we need is this measurement once. And then we can create a list of optimized tests. And the good part is we can keep this test list the same for quite a bit of time because the tests usually don't change that drastically in a few weeks. So we can update this maybe once a month, maybe once every 2 months, and then it can stay the same in our CI. And we do not have to update the list that often. So no need to query it or integrate some query to Teamscale into the CI. That makes it also, again, quite a bit simpler. We also don't need to do this measurement as often because we keep the list the same. So to summarize, we have test impact analysis, which does a test selection with regard to code changes. Here we find 90% of the bugs in only 2% of the time, but it does require continuous recording of coverage and quite tight integration into the test automation framework. So we need some initial setup effort. Pareto testing, on the other hand, is independent of your code changes, needs 11% of the time to find the same 90% of bugs, so needs quite a bit more runtime, but the coverage only needs to be recorded every now and then. How often exactly depends on the system, maybe once every few weeks, maybe only once per quarter. So yeah, this is quite a bit smaller effort. We think both of these have a completely valid cost and benefit ratio. It just depends on your specific use case or your specific requirements, which one makes sense to pick. All right, that's it for the theory. We would continue with the demo now, unless there are any questions.
So currently there's no questions in the chat.
All right, then I will hand over to Stefan for the demo.
Then hello also from me. Some facts about me. Basically, I work in the same team as Raphael, but I do not do a PhD, so I have more time to spend in the test intelligence team. All right. Few minutes, we will basically see what Raphael told us about, and we will see this in practice, how it looks in Teamscale. You should now be able to see my screen, and yes, this looks good. Today we will play developer, and the project we will be developing on is called Digital Bank or DigiBank, and it's a banking application written in Java. Our job will be to implement a feature called Quick Save, and the idea of Quick Save is that you save up a small amount of money every month, and then after some time you accumulate some wealth, hopefully. All that we have for this feature ticket is a description that we get from our project owner, and this is where we start and switch over to Teamscale. Now we can see the login screen of Teamscale. Teamscale is a web application, and you can either host the application on-prem, or we can do the hosting for you. The choice is up to you. It costs the same. And if we log in, we can see that we first have to navigate to the right ticket. And this is what I wanted to show you. This is the same information that we had on the screenshot earlier. And we can see the basically an export of the issue that we took from the ticket system. It can be Jira, for example. And what we can see is we have a ticket number, we have the title, we have some metadata, and we also have the description of the feature. But before we go into more detail and have a look at the rest of the page, let me quickly show you around a little bit, and let's have a look at the navigation in Teamscale. On the left area, we see the main navigation. And for example, we have dashboards here. Dashboards are basically an area where you can get an overview over your project. And there you can also see that we can have multiple projects in Teamscale, and you can easily switch between them. If you have a branch-based Git workflow, you can see all your branches right here. And you can easily switch between them. If you have a lot of them, you can also search. All right, let's go on. We have other areas, for example, findings, which are the results of static code analysis, or the architecture analysis, which is basically you can divide your project into different components and have a look at the dependencies between those components, and you can allow or disallow those dependencies. But for us, the most important part for the next few seconds will be the metrics perspective, and there we go into tests. And what we can see right here is an overview over our test suite. We can see that we have 108 tests, and the whole test suite takes around 16 minutes. And this is the number that we should memorize for the next few minutes, 16 minutes for the whole test suite. Now, for the last stop of our tour around Teamscale, let's switch over to the activity perspective. And what we can see right here is an overview of all the things that are happening in your project. And we can see commits that are happening in the repository that is connected to Teamscale. And we could also see coverage uploads, for example. Let me quickly change to the correct branch. And then I would like to show you how we connect commits and issues. In order to see for every feature, for every ticket, for every issue, what changes are made, we need to connect commits and the issue. And we do this by adding this specially formatted string in front of the commit message or anywhere in the commit message. You can see in this case, it's CR hash, and then we have the ticket number. And this ticket number is then mapped to an actual ticket number. And this way, Teamscale can connect commits and issues. And since commits and issues are linked, we can switch between the two. So here, for example, we have a link to the issue that the commit belongs to. And if I click on this, we get back to where we started. You can see in the bottom of the page that it also works the other way around. So we see all of the commits that happened while working in this issue. And since we know all the commits that are relevant for this issue, and we know all the changes in files that are made in those commits, we can see the affected files. And as Raphael explained earlier, for every test, we know which production code is executed while running the test. So we can also show you the impacted tests. This means those changes in those files, they impacted this single test. And now I think we have enough background to finally start the pipeline. So the story here is that now we finished developing and we want to build our project, test our changes. So let's do this. In this case, we prepared a little script. This does simulate a pipeline run. So what happens is the DigiBank application is built, and then all impacted tests are being run. While this is running, because it's a little bit boring to have a look at the console output all the time, let's click on the one test that we already have. And there we can have a look at some of the data that we have of this test. We can see that in the last test run, the test was successful. We can see the time that it took. And this is a similar picture that Raphael already showed you. We can see for every test which of the methods in the production code is being executed. So every green box right here means that this is a method in the production code that is executed while running the test. What you can see right here is that Firefox window opens up, and this is part of the testing that's running in the background. So you can see that the automated unit tests are happening. But you will also see in a second that we do not only run one test, but we run another one. And this is because while developing, I also added a new test. And new tests are always executed in order to get a test pass coverage for them. So this is why we do not only execute the one impacted test that we saw earlier, but actually two. All right. Now, the pipeline execution is finished. And if we scroll up a little bit, first of all, we see that we have failure. But we can also see that we only executed two tests. And just by looking at the time, you can tell that it did not take 16 minutes for us to get those results. Instead, it was much quicker. All right, but since we have some failure, let's try and investigate what happened. If we go back to our metrics and then tests, we can now see that we have one failed test. And we now need to identify which test failed. In order to do this, we can drill down. We can just click on those links, and then we can just trace where the failed test is. let me quickly sort by failure status. So the failure is at the top, and there we can see that this test failed. If we click on it, then we also see, let me quickly scroll down that you recognize the perspective. We can see the same things that we saw before. So we can still see which methods are executed while running the test. We can still see the status and the duration that it took. But since we have a failure, we can also see some console output. And the reason for this is that there might be some first hints of what went wrong just by looking at the console output here. In addition to having the logs present, we can also scroll down a little bit, and we have a new tree map. We have two colors there. One blue area, which is not that interesting to us. This means that we do not have any code changes there, but some coverage changed. We are more interested in the orange area. And orange in this case means that we have some code change since the last successful run of the test. And our next steps will be to really go into the code and have a look at what went wrong there. If we click on it, we get a pop-up. And if we click on Open Method, we can see the method history. So there we can see all the changes that happened to the method. We can see all the coverage uploads. And in addition to this, if I click on Compare Method, we can also see the changes that I did in my last commit. And if we scroll down a little bit, we can see on the left side, this was the old code state, and on the right side, it's the new one. And we can see those are the changes, so they are also highlighted. And we can see that while developing, we disabled some error handling. We did this by commenting this out, but we forgot to enable it again. So this looks very suspicious, and this is probably the reason for the test failing. So in real life, of course, we would have to go into our code and fix this. Here in the demonstration, we have a little script for this, but it basically does the same. It changes the code, it does a commit, and pushes it to the repository. And in addition to this, it will also run the pipeline again. If we go back into the activity perspective and have a look at the commits, we can see what's happening. And we can see that we have a new commit over here. So this is the fix that we just added to our project. And if we now wait a little bit, we will see that new tests are being executed. And I want to show you how we can see which tests are being executed. We click on the commit. We can see that we have a button, we can see that we have a button show impacted tests. And if you click on this, we can also see that just a single test is impacted. And so we know that we only have to execute this single test. While I was talking, you already saw that there was another Firefox popping up, and the pipeline is still running, but you could see by this window popping up that there was one test that was executed. Now let's go back to our pipeline run. We can verify that we only executed one test, and this time the build was successful, and also all the tests were successful. So this is pretty good. Let's now have a look at how this success looks in the test. We click on this test and do a refresh of the page. Then we can see that the latest status is now passed. And we can also see in the test execution history that after our failure, we have a passing test now. All right, so this was the the practical part of this test impact analysis, let's quickly go back to the slides and have a quick look at the summary for the test impact analysis part. So we know that our whole test suite plus build time takes around 16 minutes. And even in our little demonstration with a pretty small test suite, we can see that before the original test suite would have been finished, we had a reduced, impacted test suite run. We had our first feedback. We were able to identify the exact issue. We were able to create a bug fix for this. We were then able to build and run the whole impacted test suite again, which was only one test in our case, and we got successful feedback. So in less time that it takes to run the actual test suite, we did not only find the bug, but fixed it. And this is really the important part of test impact analysis. You get really, really fast feedback, and you can act on this feedback very quickly. All right, so this is the first part of the demonstration, the test impact analysis part. I will now switch over to Pareto ranking, but we still have time, of course, for questions if there are any.
Hey, do you hear me?
Yes, I do. Yeah.
Thank you for the presentation. And yeah, I really see a value in this quick response for the failed tests. The question what I have is, right now you have, I guess, Java application. And if I wanted to do same thing with Swift-based iOS application, where we have UI tests in a separate repo based on Appium and JavaScript, how easy would it be for us to do same thing?
So basically, the underlying technology is different for every programming language. So what we do need is test fast coverage, and you're right. In this case, we showed it for Java, but if you use a different language, then the only thing that really changes is the way that you collect the coverage. The basic test impact analysis techniques, they stay the same. So imagine you have, if you have a look at this image right here, all that we need is information about the methods in your code and which of them are executed. And the language is not really necessary, not really important at this point. But of course, we need to be able to have to gather coverage for this. And I know that it's possible for JavaScript. I would have to check if it's possible for Swift, maybe Sven or Raphael.
It is. Yeah,
Okay.
for Swift, we can collect coverage. The special part is this test case specific coverage. There are different ways to achieve it. One is to just execute every single test individually and then measure its coverage and then stop the recording. Might take a bit longer than normal test execution, but usually that is one way how this can already be achieved. And yeah, it doesn't really matter if it's in a different repo or the same repo. Yeah, usually not a problem with having different repos. We also, as I mentioned, did it for manual tests before. The environment in that direction usually doesn't matter too much.
Okay. Yeah, I have some more specific technical questions, but I think it's better if I investigate it myself. Thanks a lot.
And if you want, we can have a talk later after the workshop. I mean, we do this every day. It's possible that we can help you.
Yeah. Thanks for the offer. That would be nice. Maybe not today, some other day, but would be nice. Thank you.
Sure, absolutely. All right. Any other questions before I move over to Pareto ranking? That does not seem to be the case. Then let's switch over. First of all, let's navigate into the correct perspective. So we it's in this case, it's under test caps and then test selection. And if we remember what Raphael told us earlier, then test impact analysis and Pareto ranking, they basically do the same, but they have a different, like, they are more or less dynamic. Test impact analysis is more dynamic, which means that for every change set that you have, you get the impacted tests just for those changes. And this also means that for every pipeline run, you need to ask Teamscale which of the tests are impacted right now. So this gives very, very good results, very fast results, but can be a little bit tricky to set up. And the easier part is Pareto ranking, where you get a static list of a smoke test suite, basically, and you run the same test suite over and over again for several weeks or months. And then after some time, you just refresh the list and then use the same list again for a certain amount of time. And now let's have a look at how we can really generate this static list in Teamscale. First of all, we have to select tests that we want to include in our tests, in our smoke test suite. And in our case, I will just select all of the tests that I have, because there's, we have 109 at the moment of them. So there's not really much use in filtering this down more, but you can filter it if it's necessary for you. So if you only want to have the test suite for a specific area of your code or some tests included there, you can already filter before you start Pareto ranking. And you can do so by creating some test queries, which allow you to filter by name, by duration, and by result, for example. But as I said, in our case, we want to have all tests. So I selected all of them. Now I have to click on all selected, add selected tests. And then we can see a graph that we have seen earlier. This is basically the same image or similar image that Raphael showed us earlier. And we can see that we have a relative coverage on the y-axis and time on the x-axis. And what you can see right here is that we have those jumps or those leaps in relative coverage. And then we have a small plateau, then we have another jump, then we have another jump, and then we have a lot of plateaus and only very small jumps. And as Raphael explained, the idea of Pareto ranking is moving all those big jumps to the left and moving all those plateaus where we do not really gain any more coverage to the right. And in Teamscale, this is pretty easy. I just have to click on prioritize tests and I have to perform Pareto ranking. And then after a few seconds, we get our optimized graph. And just by looking at this, we can see that we can get almost all of the coverage in very little time. You can see that we have this preview slider over here. This is the slider for our test budget. In our case, it's about 2 minutes. And basically what we want to do is we want to hit this area over here where we have much more relative coverage and in only a little time. And then we want to avoid the big plateau area on the right. And we can do so by moving the slider over here, and you can see that you get instant feedback. And now let's try and hit the sweet spot right here. But now I overshot a little bit. So what you can see is we had a change in colors. Let me wiggle around a little bit more. You can see that the green areas, this would be coverage that your test suite is able to achieve. And if it's green, then it's also achieved in the Pareto optimized test list. The blue areas mean that it is possible to achieve this with your whole test suite, but because our test budget is too small, we do not execute those methods of the production code. So what we want to do is we want to minimize the blue areas or the blue boxes. So let's increase the time box a little bit, and then we are back on our 2 minutes and something, and we can see that we have 100% of our relative coverage in just 2 minutes instead of 16 minutes. And as you can see, just by watching at the clock, this was much faster than the test impact analysis, and there's much less moving parts because we're done already. So this is the optimized list. All that's left for us to do is export the list, and we can do so by either downloading a CSV file, so you can really just put it in your pipeline and have it there. But if it's easier for you, you can also use a API endpoint that Teamscale offers, where you can download the Pareto optimized test list. All right, this was the part about Pareto ranking. Do you have any questions about this?
Maybe one question. Does
Sure.
this Pareto ranking also take into account the setup of a test? You mentioned the login page and so on.
No. If you only have a look at one test specifically, then no. What you can do, if this is necessary for you, you can group those tests. This is where it gets a little bit more tricky technically, but it is possible to also include some of the tests all of the time.
Mm-hmm.
Because obviously it makes sense to log in before you do the rest of the tests.
Yeah. So you need to take the into account, how do I write my tests in order to be able to use the Pareto ranking?
I would say it depends a bit. So what you can also do is, for example, we are now doing this on method level. If you, for example, have a setup for every test class, we can do the same on class level. And then the setup is always included for a class. And we can just sort based on classes. The results will be not quite as good, but it will still be quite a bit better than default execution order. Or as Stefan mentioned, what we can also do is, in theory, work around the limitation by, if every single test needs to do it, we can just include it in the measurement of every single test. Yeah, depends on how the setup looks. If it's a class setup, if it's a global setup, or if it's a individual test setup. So
I think we should talk about it maybe separately in our specific project environment or setup.
Yeah, that
Absolutely.
makes sense.
Thank you.
All right. Do you have more questions? If not, of course, you can also ask questions later, but if there are no questions right now, I will hand back over to Raphael.
All right, thank you very much. Then I will continue with the last part of today's talk, which consists of 2 case studies where we actually use these techniques in practice. And the first one is at BVK, or Bayerische Versorgungskammer. And what we looked at there was a pension fund management system. They had relatively long-running tests of a little over 10 hours at the time we did the evaluation. And what we did there was a retrospective evaluation of the procedures. So we basically look back in time and look how well would it have worked in the past for you to evaluate which to choose. And this is done usually with a pilot project. And what this usually looks like is we first start with a kickoff, where everyone is told what the project will look like and what the plan is. Then we set up recording for the test-wise coverage and do a validation of this, so that all the tests that you expect to be there are included, and that the data looks correct, that all the code is there, and everything looks how it should for your system. Then we do this, as I mentioned, retrospective evaluation. So we look at how well would these techniques have worked in the past, because we know past test failures, and we then look at would we have found these, and how long would the tests have run. And finally, we do a result presentation, and if everything went well and we have good results, we will decide on a technique and hopefully roll it out. Okay, before going into the evaluation, very briefly about the technology and for collecting test-wise coverage. So in this case, it was a Java system. So what we have is we have the application, in this case, a Java application, and we have a sort of test system, which can either be manual testers or an automated test runner. And on this, we then install our test-wise coverage profiler. And just like a normal profiler, it looks at, while the application is running, we look at which lines were executed, and we can then get a report that shows, in this case in green, everything that was executed, in red, what was not executed, and in yellow, lines that were partially executed. And to get test-wise coverage, we need some additional info, which is the events of the test starts and test stops. So this system, either a manual tester or the automated system, when it starts a test, it sends a signal to the test-wise coverage profiler that now a test is starting, and we then write coverage for every single test case. So we get reports, and not one global report for everything, but one report per test case. And these reports are then uploaded to Teamscale, and then we do this what-if analysis. So what if we had used it in the past? And in this case, we focused on what's the benefit. So we looked at how much time we can save. In this case, we looked at executing, first of all, if we execute all the selected tests, how much time do we save? And this is the graph over the last about 1.5 years. And a nice part that is immediately visible is that almost all of them are below half of the execution time every single test run. And sorry for the graph explanation. On the x-axis, we have the different dates. So one spike here is one test execution. And on the y-axis, we have how long did the execution take. And now we shift this over to a different type of graph, which is a histogram. And here we have buckets, and every single bucket represents a test runtime. So for example, smaller than 20 minutes. And every day that had a test runtime of below 20 minutes will be put into this bucket. And then we have the next bucket, 20 to 40 minutes. And then we put all the tests that were between 20 and 40 minutes, all the test runs, into this bucket, and so on. And we can see that on 93% of all the days, we have a test run time of less than 17%, so quite short on almost all the days. And so these results already look quite promising for test impact analysis. Then we also looked at Pareto for the evaluation, because we wanted to compare which techniques does how well here. And here we looked at 5% of the execution time, and we found that every single time we had at least one impacted test. So what we wanted to have a good spread over the whole test suite. Every single time we had some of the impacted tests that actually cover changes as well. And overall, we had about 17% of the impacted tests in our 5% of execution time selection. And yeah, overall here we achieved with just 1 hour of the overall runtime, over 99% of the relative method coverage. So we can basically cover the whole system fairly quickly, which also looked quite promising. So then we looked at how can we actually use these techniques. And the first one we looked at was test impact analysis. And the status quo was there was a nightly rerun all. So every night we just first did a build that takes about 45 minutes, or took at that time about 45 minutes. And then we had a big test run with all the 10+ hours of tests. With test impact analysis, what we can do instead is time box. So we have during the day tier time boxing. So we have time boxes of 2 hours, 1 hour reserved for the build, and then maximum 1 hour for test execution. And in most cases, we know this to be quite short because when we looked at that histogram, most of it is quite far to the left side. So in most of the cases, we will execute all the tests in test impact analysis. So we will get fairly quite valuable feedback early on. And if we ever miss any of the failing tests, we can still even do the nightly rerun all, and we only gain a lot faster feedback. We gain feedback during the day and not just on the next day where we might already have be in a completely different mindset. We already have worked on different topics, and then we need to integrate the feedback from yesterday's test run. And second scenario, Pareto testing. Here we suggested a similar application. We also have time boxes of 2 hours, and here we can decide exactly how long we want the test to run. So we do a time box of 1 hour for the build and 1 hour for test execution, and we just select a Pareto list that takes around about 1 hour. And then we can also just have a time box of 2 hours that gives me fast feedback during the day, and yeah, find most of the faults early on, and the rest will be picked up at night with this rerun all that we can still execute. And yeah, every now and then we have to update the coverage. And as mentioned before, here no deep integration to the CI is necessary, so we can just use this static test list and have it run for quite a while. And since this looked quite promising, we decided to go with Pareto testing because it is less effort and yeah, needs less maintenance, and the results were quite good. What we found looking at it afterwards, after having it run for a while, that we can find around 70% of failing commits in only 5% of the test run time. And so this has been in use since for some of the projects at BVK and sped up the test execution quite a bit. That was this case study number 1. The second one is at Dolby, more specifically Dolby's audio division. Here, what led to quite long-running tests was a combination of parameters. For example, as I said, they do audio, so they have different bit rates, different speaker configuration, different frame rates, and they do pairwise testing with these. So that quite quickly leads to a lot of different tests that test with different parameter configurations. And they had test suites of test runs of around 3 to 12 hours because they had so many different configurations. And their goal was to have it down to 10 minutes, so quite a big discrepancy there. And yeah, we introduced test impact analysis there quite a while ago, or rather they introduced it. They did quite a bit of it themselves. And yeah, with test impact analysis, we could guarantee these 10 minutes of test execution, so cutting off after 10 minutes, while making sure that almost all the relevant tests for a specific change are still running. And that despite the test suite growing by 57% since the time of introduction of test impact analysis. Because we already mentioned different technologies, they are using C++ and Python. So this we do not only support Java here. Yeah, we have a bunch of different technologies that we have already done this for. All right, that is the second scenario. Are there any questions at this point? If not, I want to already thank you very much for participating and give over to Sven for a few final words.
Sure. So be stealing back the screen. Of course, if there are more questions at this point or at any later point, please feel free to ask. We'll be here for a couple more minutes. But since nobody's raising their hand at this very moment, let me use the time to thank you all for participating and for asking the many interested questions. As I announced in the beginning, we would love to get some feedback from your side on our workshop and format. So we'll be starting our feedback poll now to give you the opportunity to do that. While you're clicking the buttons, some of you already asked for continuing some discussions with detailed questions offline. We'll be, of course, be following up on that. And if you now say, oh, this was actually interesting, and I know a couple of more people at my company who should learn about this, then we're also happy to conduct this or a similar workshop, somewhat tailored probably to your technologies in your environments, on your side, either on-site or virtually, however you prefer it. So please feel free to reach out to us, and if you're interested in showing the test selection ideas to your colleagues, your team, your boss, or whoever should learn about this. Also, as you might or might not know, we have a couple of more topics or ideas around testing and optimization of testing. Most prominently, our test gap analysis, on which we had a workshop end of September. So if you're interested in that topic, namely the idea how to find gaps in our test suites, so places where we're still missing tests and should probably add some, then feel free to check out the recording. You see the link here on the slides and in the chat at this point. So you can look up on these details as well. And this is my last slide for today. So all that's left is to say thank you again and wish you probably a good lunch. And as I said, if there are any questions, we'll be around for a couple more minutes. So please feel free to ask. And if the questions come later, feel free to send us an email or give us a call anytime. Thanks, everybody.